Okay, so hi everyone, Senan on this side, and in this video we are going to solve this path with minimum effort problem. So this is a medium level problem, and assume you are a hiker preparing for an upcoming hike. You are given heights, a 2D array of size row comma columns, where heights of row it represents the height of cell row comma column. You are situated on the top left this and hope to travel to the bottom right. Zero indexed. Okay, you can move up, down, left or right, and you wish to find a route that requires the minimum. The route's effort is the maximum absolute difference in heights between the two consecutive cells of the route. Return the minimum effort required to travel from the top cell to the bottom right. Anyways, if you have this sort of definition of a matrix traversal, you should be pretty sure that it is more or less a graph problem and not a matrix problem, right? Now you see in this example, from 1 to 3, it would take a maximum effort of 2. 3 to 5, it's again 2. 5 to 3 is 2, and 3 to 5 is 2. So the maximum effort required from this journey from 1 to this 5 is 2, right? Let's look at this case. If you go from 1 to 2 to 2 to 2 to 5, that would be effort of 1 here, effort of 1, effort of 0 here, effort of 0 here, effort of 3 here. So the maximum we have to maximum in this path is 3, and we need to minimize that maximum effort. So we have to maximize. So given a maximum value, you need to minimize that. Given the maximum effort along the path, you need to minimize that maximum effort. So it's a nested thing. Minimize something that is a maximum. Okay, so how do you do this? So basically what I can do is use the logic of Dijkstra's algorithm. If you've not watched that video yet, I highly recommend that to watch that first before going through this, because I won't be explaining the Dijkstra's but the logic behind this question. Now let's look at the implementation of how exactly you get to the solution. What you do, you get the rows and columns, I say n and m, and I take a visited array, or maybe a distance or the effort array. I mark this as visited back because it's the most obvious thing. Anyways, what I do is in Dijkstra's you use a priority queue, and in this visited array I assume the maximum effort to reach any element is int max, the maximum, right? That won't be the case, but that is the max. Now what I would do is, since I'm standing on this first, so the effort requiring me to stay at this first index is what? 0, because there is no effort in staying at the same position. So I say visited of 0 0 is 0. Now this dr and dc is just for proper travels, easier way of writing traversal, up down left and right. We'll see it later on. Now what I do is I push this into the queue, and what am I pushing? The effort and the row and column, like this. And if you see, my priority queue is a min heap and it is storing vectors, and the container to store this vectors is vector of vector int, and we are using this greater so that we can get the min heap out of this. So I am storing the effort, so this is what we are most concerned about, right? And this row and this column. Now what I do is I take out the top element of this priority queue and remove that from the priority queue itself, and I store these values, right? What is the current effort till now that I have attained? The row and the column. Now what I do is I try to traverse the neighboring nodes. So number of rows, new row is row plus dri, new column is dci. So we are having this is going right, this is going down, this is going left, and this is going, okay, so this is going up and this is going left, right? And again I'll just say that again, this is for going right, this is for going down, right, down, left and up. So that is what we are trying. Now what I do is I say, if I'm this new row and new column is within my matrix, what would the new effort to get at this? So the new effort would, first of all, the absolute difference of this node from the node I am coming from. So this is basically calculating the difference between, let's say, this and this. This is the row and column, this is the new row and new column. So the difference is what? Difference is 6. So this is 6, and what is the, along this path, what is the maximum current effort that I had to reach that? So that is what the current effort is. So I would choose the maximum element, right? So in let's say I'm going this way, say 1 2 8 3 and 5. At going 1, the maximum effort I required is 1. From going to 2 to 8, the maximum effort is 6, because 2 minus 8x, and it's more than this effort, 1 out of 1. Now when I go to 3, the difference is 5, so the effort is not 5. So I'm calculating the maximum effort, so it would be along this path, the maximum effort is what? It's 6, right? Even though the effort required to jump this, it's 5, the maximum effort from going from this to this is 6. So that is what I'm trying to do. So the new effort that I require is either the current effort or the absolute of the difference, whichever is the maximum is the effort required to reach this new row and new column. Now if I say if I have visited this, if the visited this new node and the new effort is less than the what is already stored as my effort in the visited array, I update that and pass that into the priority queue. This is the classic way of doing Dijkstra's algorithm. And in the end, after you have traversed the graph in all possible ways, what you do is you return the value at the last node. Since this is an 2D matrix and we know there would be a value at this position, a value at this position, and there are basically no obstacles in this grid, so we know that the answer would exist and would be placed in the lastmost position. Let's say if the array is of n and m are both 1, so we only have a single element, so in that case we would push this. We won't be having any neighbor, so we won't be pushing this, and since we had visited of 0 comma 0 as 0, we would return in that case 0. So yeah, that was the whole video. The time and space complexity would be same as the Dijkstra's algorithm, that is E log V. So V number of edges is what, n times m times 4 speaking, and the number of vertices is what, n times m. So that is the time complexity, and space complexity is basically of the priority queue and the visited array. So both are of size n times m. In the worst case, visited is obviously n times m. Priority queue could be n times m, n times 3 if you want, because you are storing 3 elements. And yep, that is the whole time and space complexity. Hope you understood this question, and yep, thanks for watching, and I'll see you in the next video.